So we're going to continue on with example number 3 on page 21. It says here, the concentration in milligrams per liter of medication in a patient's blood as time passes is given by the data. Now, this is a data collected. What are the two things that they're connecting in here? The two information that they're connecting. They're connecting the time and then the concentration. It means the amount of the medication. Amount of medication okay. It says here, determine the equation that models this data. Let's first take a look. What does that kind of look like? Okay, because remember, the only thing that we're going to focus on in grade 11 are either linear or quadratic. Linear or quadratic. Linear, if it kind of resembles a straight line. Quadratic, when it kind of has like either going up like that, it's called a parabola, or going like that. Okay.
Are we also going to deal with sporadic? Are we also going to deal with sporadic?
No, we're not going to focus on that one because we can't really see a trend if it's more sporadic, out of place, out of whack. I want to tell you this, that sometimes it's not going to be a nice, neat points lined up together. Okay, I want to tell you that. And we've seen that before, right? It's nothing straight line. But if we kind of take a look at it, does it kind of like a straight line? Right? Those are called scatter plot. The scatter plot, we have to take a look what kind of graph that kind of resembles. So without much talking, so we know how to do this. Let's put this on our L1 and L2. Now that we've entered the data on L1 and L2, we should figure out what would our X min and X max will be so that we can see all of our points on our grid, on our screen. Any suggestion on what we should do for X min and X max? Zero? X max, you said 3. Okay, 3 is okay. You could put 2, but if you want extra space, 3.
I always put extra.
Yeah, extra space. Yeah,
Makes it easier to see the graph.
exactly. Y min, these are your Y values. What's our minimum? 0. What do you think our maximum? 100. Okay. Okay, well, those are the min, max for X and Y. We can just pick a scale. Scale doesn't really change anything. The only thing it just change is like the tick marks, the number of tick marks on your grid. So looking at the X, what do you think our X scale should be?
0.5?
Yeah, you can go 0.5. That's okay. So that means every tick mark is 0.5. Yes. What about the y?
10 or 5.
10 or 5?
20.
Somebody says 20. It's okay. So if you put 5, then that means you have more tick marks, right? Because it's counting up by 5. 5, 10, 15, 20, up to 100. If you put 10, you have a little bit less tick marks because they go up by 10. 10, 20, 30, 40, up to 100. And if your scale is 20, what would it be? If your scale is 20, then it would be, yeah, there's going to be,
Few.
it's going to be farther apart, right? Because it's 0, 20, 40, 60, 80, 100. So does it really matter? Not really, right? So pick whatever you like. I'm going to pick 10. Not too many tick marks and not less. Okay. So I had to check if my stat plot is on. Yeah, so second function y equals, it's still on for me. Change your window. Okay. Now, looking at that, what does that kind of look like to you? It kind of looks like going up like that and then down. Okay. Quadratic. So, the next thing that we're going to do, so we kind of looked at the graph, it's like, oh yeah, it probably looks like a quadratic regression. So let's go ahead and determine the quadratic regression equation. So how do we do that? So let's go ahead and do that one. Okay. So you go stat button, and then you're gonna go to calc on your screen. So you're gonna press the right arrow key to go to calc, right arrow key to go to calc, and then we want to go quadratic regression. So that's number 5. So press 5. Now it's gonna take us to this screen. It's gonna take you to the screen. We have to use the arrow key down so that we can go to store regression equation. Okay. Hold on. Okay. Store regression equation. Okay. What are we going to do? Vars. And then go to y var. So how do you go to y vars? Go to the right arrow key, right? And then we want to just press 1 for function. So press enter. This is where you enter like 4 times. 1. We're going to paste it on y1, yes. Press enter and then enter again. Okay, so now this is a quadratic regression equation. Remember, we want to make it as an equation. So y equals 2. We're going to replace the a with the a value. We're going to replace the b with the v value. And then we're going to replace the c with the c value. Okay, so a negative 74.83, rounding it off to 2 decimal places, x squared, plus 170.8 0.96x plus 3.77. 3.77. Doesn't matter. Okay. Is everybody okay here? Okay. What does that really mean? What does that mean? This equation connects the time and the amount of the medication in our blood, or in that person's blood. Okay? Yeah, that's a negative. Yeah. You should get, did everybody get negative 74.83? Yeah? And then the B is 170.96. If you round it off to 2 decimal places. And then for C, did you get 3.77 if you round it off to 2 decimal places? Okay. 3.80? Okay. Okay. That's a slight change. That's a slight difference, okay? Now, let's take a look again. Okay. There shouldn't be a difference, but let's take a look. Go to Stat. Edit. Did you get 0.51, 1.52? That's okay. Okay. Now go on L2. Did you get 0, 78.1, 99.8, 84.4? Did you put 50.1? Okay. Okay. And you got a little bit different, a little bit of a different answer. Okay. Okay.
What does this mean? I did it first time, but I want to try it second time, so I got this. What happened?
Oh, this is a different calculator.
But I did. I did first time, so I want to try it second time.
Yeah, I think it's this one, L1. So you go Stat, Calc, quadratic regression, bars, y bars, 1, 1, 1, invalid dimension, invalid dimension. It's right. It's there. That's why.
So how can
It's L1. L1. That's why your X value should be coming from L1. And your okay. So that's why. Go ahead and do bars. Okay. Is everybody okay here? I've touched base with some people. I tried it again and I got 3.77. Okay. So, what does that say? What does the y represent in this situation, in this equation? What does the y? Okay. Yeah. Okay, I'm just going to ask you to pause for a second and then so we can go through this because I know some people are talking and yeah. I just want to ask you, what does the y represent? The y is the concentration. This is your x and then the y. So y is the concentration. What does the x represent? The x represents the time, right? The time in hours. So we're going to use our regression equation to figure out what is the medication, amount of medication after 1.7 hours. So in this situation, they gave us, which value is this? Is this your x or is this your y value?
X.
Yeah, so they're giving us the x value. So given x is equals to 1.7 hours. So they're giving us the x value, and then what we're going to do is we're going to use our regression equation to calculate the y. So how do we do that? You remember? Okay. Yeah. Remember that yesterday?
No, I don't. I wasn't here.
Oh, okay. Well. Okay, good. Let's write it down. So you're given the x, we're going to figure out the y. So you're going to press second function, trace, second function trace, and you're going to pick 1 for value. Okay? So let's do that. Second function trace, second function, and then the trace button, and then you're gonna press 1 for value. Okay. Oh, that's a nice graph. That's a beautiful graph. Now, can you see that the x is blinking? Yeah, it's blinking because they're waiting for us to enter the x value. So we're gonna enter 1.7. Okay. So what does that say? If x is 1.7, if x, which is the time, is 1.7, what is the y?
78.14.
1.4. Okay, so we're gonna go y is equals to 78.14. And what is the y value again? Y value is talking about the amount of medication. So what's the unit there?
Milligram.
Milligrams per
Per liter.
liter. Yeah. Is that good?
So you just have to write.
Now let's take a look at this one. Take a look at letter C. Predict the concentration of medication in the blood after 4 hours. After 4 hours. So, no, it won't be.
50.1 times 2.
Okay, so what we're going to do is we're going to use our time, we're going to use our equation to figure that out. What did they give us?
Wow.
They're given the x being 4 hours. Okay. Now I'm going to take a look again. So second function, trace, second function trace, and then we're going to put 1. We're going to press 1. It's waiting for us to enter 4 hours. So let's enter 4 hours. Uh-oh.
That's what I get.
Uh-oh. What's going on?
X is 2.
Because our window is
Our
3.
window is
Yeah, you're right. Now it's saying it's not valid because our window only goes up to 3 for x.
5 or 4.
So we have to change our value. So
So should we
yeah.
do 4
So
or 5?
change your window. Okay. So what do you want? Should we go 4 or 5? Yeah, let's go 5 to have an extra room. Okay, now try it again. Second function trace. 1 for value. Okay, now that's going to give you that graph again. And then we're going to go what did I say?
4.
4? 4? Hmm.
4 equals 6.
Now, does that make sense to us? Negative
500.
negative 509.66. What do you think? So your answer was negative 509.6 milligram per liter. Now, you're probably thinking, oh, that's what my answer is on my calculator, but does that make sense to us?
I don't think so.
Can we have a negative amount of... No, right? So in this case, predict the concentration. So the concentration is what? How much concentration can we have in our system? 0. Yeah. So that means although our
We're done.
model or linear or quadratic regression goes like this, after 4 hours, really, in reality, we should have 0 in our system. Meaning that, hey, that's what your kidneys do in your body, right? It eliminates things. You excrete them, right? So at the end, in 4 hours time, is there any more medication in your system?
It's done.
No more. No more. Right. So after 4 hours. Then you're probably thinking, well, what does this negative mean? What does this negative 509.66 mean? That's just going through the model that we have, okay? If they're following the model, the y would be negative, but it's really, in reality, you can't have that much. You can't have that negative amount of medication in your system. Okay? So, what have we done so far? We took our time. We took our time. What did we do? This is the only thing that we did. I'll write it down. In this particular topic, you're given data. Okay? So in this particular booklet, or in this particular topic, we're going to be given a data in some sort of a table. And then what do we do with that? Then we determine regression equation. Okay, so once we have the data, we figured out the regression equation. And which two regression equation that we normally do, that we're going to focus on? Either linear, if it kind of looks like a line, it's a linear, or it could be a quadratic. Yes, those are the only two that we're going to focus on. And then after that, we're going to use the regression equation to solve for y value when given the x value. So once we have the quadratic or linear regression, we're going to use that regression equation to solve for y but we have to give you the x, right? And to do that, you've written it down already. So you go second function, trace, and then you're gonna press 1 for value. Now, when I put a box around the word, it means an actual button. So you're gonna press the second button, and then you're gonna press the trace button, and you're gonna press the 1 button to go to value. And then you enter your value, and then your y would come out. Okay? So that concludes that. So it wasn't that bad, right? Once we got to know, once we spent a little bit of time, took our time with linear modeling, quadratic modeling, took our time with these examples, talk about it, it's not that bad. Okay, so now, I'll let you copy this down.